We're recording. Let me share my screen. All righty. So, working with virtual hard disks is what we're going to be working on tonight. So, virtual hard disks can be one of three types: fixed size, dynamically expanding, or differencing. So, fixed size is recommended when the VM needs to run disk intensive application. And the reason that they do this is if you give them dynamic disks when they're like that, they can just go bananas and eat up a ton of space. Dynamically expanding, somewhat slower than a fixed size, but unless the VM is running disk intensive applications, dynamically expanding disks are a good choice. So if you're doing something that's smaller and less rough on your hard drive resources, that one can be good. I personally try to use fixed disk on most VMs just because you never know. And then there's differencing, which uses a parent-child relationship where the parent is dynamically expanding or fixed disk, and the child is a differencing disk. So next we're on to creating and modifying virtual disks. Virtual disks can be created when a VM is created or with the new virtual hard disk wizard. You will need to choose the format from the following options: VHD, VHXD, or VHD set. VHD is the original virtual disk format and provides backwards compatibility. VHDX is the default option, supporting virtual disks up to 64 terabytes. VHD set is a shared virtual hard disk used with VM cluster configurations when multiple VMs have access to the same virtual hard disk for fault tolerance and load balancing application. So if you have something that you're going to be doing load balancing on, or that you need to have like additional backups of, that's what you usually use that for. You also need to choose the disk type and specify a name for the virtual disk file and the location on the host where it is stored. I suggest that if you are using these, that you don't just randomly make up names. Having a naming convention so that you're not like, well, what does that mean later on, is very helpful. And I say this from experience. Okay, so here's how we work through the hard disk wizard. So choose your disk format, and you see there's the three options. And there's your disk type. And the nice thing about these wizards is it doesn't just have selections, it actually gives you a little bit of an explanation onto what they are. And then you have your size requirements here. New virtual disk can be created when a VM is created or with your disk wizard, and then you can create a default location unless you specify a different path. You can modify certain aspects of a virtual disk in the Edit Virtual Hard Disk Wizard. Compact, convert, expand, merge, or reconnect are the other options you can do. Pass-through disks, first of all, before I hit this, that should make sense to you guys, but do you have any questions? Okay. Pass-through disk is a physical disk attached to the host that's placed offline so that it can be used by a VM instead of or in addition to a virtual disk. They have a modest performance advantage over virtual disks, but it lacks flexibility of a virtual disk. The advantage is that you can do VHD disks are limited to 2 terabytes, but if you use something like this, it can be much bigger. And this just shows you an explanation. The only time I've really seen this is if you have a lot of like dedicated VMs, like say you have a VM that you know for sure is going to be using a huge hard drive space, and you're like, okay, rather than having this particular hard drive shared with a bunch of other VMs that you know are going to be on here, let's have a dedicated pass-through disk that we want to use just for this one. I have seen that happen quite a bit. Storage quality of service. or QoS enables administrators to specify minimum and maximum performance values for virtual hard disks. The maximum specified value limits a VM access to a virtual hard disk to prevent it from consuming too many storage resources. Can affect other VMs access storage, and there's no can, it will, especially since so many network systems have, when you're doing multiple VMs, you use multiple, you don't just put one. Most of them have like 10, 20, you can have much more than that. So if you have a whole bunch of them on there and suddenly you have one that's just eating up tons of resources, all your other stuff's going to get tanked as well. Storage QoS can be set on IDE and SCSI virtual hard drives disks. Okay, and here's your stuff on that. That's what your screen looks like. Requirement scenarios. Hyper-V is used in a scale-out file server, or it's used with a cluster shared volumes. There are storage QoS policies. Two types exist. There's aggregated, which applies to the minimum and maximum IOPS, IO operations per second, values to a set of virtual disks working as a whole. So basically, it's like it gives you a scale, and then it gives you a warning after it hits that section. Then there's dedicated policies. And this applies to the minimum maximum values of each virtual disk that the policy is applied to. So with that one, you only have, like, say you have 1 through 10, and the dedicated policy is only applied to 1 and 5. You can use that for that. External virtual switches binds a virtual switch to one of the host's physical network adapters. This allows VMs to access a LAN connected to the host. Only one external switch can be created per physical network adapter. You use an external virtual switch when external computers must have direct access to the VM, or when the VM must have access to the external network resource. Having more than one physical NIC installed on the host computer is recommended if you're using external virtual switches. You can dedicate one of the NICs to host communication, and the other one can be bound to external virtual switches. When a NIC is designated for use in an external virtual switch, Windows binds the Hyper-V extensible virtual switch protocol to the physical NIC and unbinds all other protocols. And this just shows you an explanation. So this is an example of host physical computer. And then this one you can see you have your VM 1 and 2, and then you have your external virtual switch, and you can see your physical network switch and host physical and virtual switch NIC down there too. Does that make sense? Hopefully. Okay. Internal virtual switches. These allow virtual machines and the host computer to communicate to one another, but doesn't give VMs access to the physical network. An internal switch isn't bound to any of the host's physical NICs. A virtual switch is created, but it's internal to Hyper-V and can't be seen on the host computer. The new virtual NIC attempts to get an address via DHCP, but because it doesn't have a connection to the physical network, it's assigned an API-PA address. This is used when devices on physical network don't need direct access to the VMs and vice versa. And this just shows an example of what that looks like. So as you can see, they chain instead of looking like kind of like the spider web, this one chains down to the physical network switch. Private virtual switches. These are similar to an internal switch, except that the VM connected to the private virtual switch can't communicate with the host computer. Creating a private virtual switch doesn't create a network connection on the host computer. A private virtual switch is used when you want to isolate the VM connected to the network from all outside communications. You might use this setup as a domain testing environment or a development network. In fact, usually that's what I see it set up for. So you can see here, it's instead of having any sort of connection, it's just like, it looks almost like they do when you have an air gap server. It's just, there's a break right there. Communicating between Hyper-V switches. What if you want to isolate VMs in their own private network, but you want them to be able to access other private networks or an external network? You can do this in two different ways. Create an external and a private virtual switch, then configure one VM with two NICs. That's kind of the nice thing about doing virtual. You can do all sorts of different ones this way. Create an internal virtual switch and enable routing on the host machine so that it routes between the internal and physical switches. And here you see a nice explanation. So you have the two VMs, private virtual switch, then there's a VM with a RAS, and you can see what that looks like down here, how it chains down to the actual physical network. And then you just see the other with our RAS routing enabled on this one. Creating a virtual switch. Creating a virtual switch in Hyper-V Manager, or create a virtual switch in Hyper-V Manager by clicking Virtual Switch Manager in the Actions pane. You can edit an existing virtual switch or create a new one. Choose External, Internal, or Private and click Create. In a Virtual Switch Properties window, give the virtual switch a name. And just like your folders and hard drives, make sure it's not like Virtual Switch 1, Virtual Switch 2. Yeah, you can do that, but in my experience, it's better to actually give them a little more meaning to that so that you're not like, this is Virtual Switch 1 through 10, and I have no idea what they go to. So it's just easier. You have the following options for configuring the switch. You have connection type and then VLAN ID. And so this is what it looks like, the Virtual Switch Manager. And you can see your external, internal, and private. And then this is basically your properties window when you create that. And the notes pane, if you're going to not do any specific names, you at least need to put notes in. Configuring MAC addresses. VM network adapters must have a unique MAC address on the network. Hyper-V must assign a MAC address to each network adapter connected to a virtual network. Assign dynamically to the adapter from the pool. The pool contains 256 addresses by default, but that can be changed. To expand the pool, changing the second to the last byte of the maximum address is best. First 3 bytes are the OUI assigned by Microsoft, and the last 2 octets are the server's physical NIC. So this is an example of MAC address range, and then you can always do a min-max if you want to change that. I haven't had to do that with mine because I've been working with small to medium businesses, but if you're working with like a really big enterprise setting, you might have to do that, and this is where you would do it. Adding and removing virtual network interface cards. It's really not that difficult. A VNIC is created when you create a VM and you have the option during VM creation to attach it to a virtual switch. You can also add a VNIC to a VM after it is created. To add a VNIC, select the VM in Hyper-V Manager, click Settings in the Actions pane, and click Add Hardware. Choose Network Adapter and click Add. So it's very similar to just doing it with the physical one, except instead of searching for the physical hardware, you just add it this way. Once a VNIC is created, you can remove it by clicking Remove in the Settings window of the VNIC. So here's your Hardware Add Hardware screen, and you select your network adapter, and then here you have your network adapter settings. Advanced virtual network configuration. So aside from connecting a VM's network adapter to a virtual network switch, you might need to perform other configuration tasks related to a VM's network connections. The following sections cover these advanced configuration tasks. You have hardware acceleration on your vNICs, advanced vNIC features, NIC teaming, synthetic versus legacy network adapters. Remember, legacy means old. Fiber channel adapters. Virtual NIC hardware acceleration. 3 hardware acceleration features for vNICs. There's virtual machine queue or VMQ. This accelerates the vNIC performance by delivering packets from the external network directly to the vNIC. There's IPsec task offloading. The physical NIC handles much of the processing required to handle IPsec security associations. And then there's single root IO virtualization, which enhances the virtual network adapter's performance by allowing a virtual adapter to bypass the virtual switch software on the parent partition, which is the Hyper-V host, and communicate directly with the physical hardware. Configuring vNICs with advanced features. In the advanced features dialog box, you can configure the following features and security options. You can do MAC addresses, enable MAC address spoofing, which when you're doing virtual stuff is very helpful. DHCP guard, router guard, protected network, port mirroring, and device naming. And here you can see the advanced features screen with all that information on it. Configuring NIC teaming. Now, before I start that, are there any questions? I know a lot of this is just you guys probably drooling in the corner going, oh my gosh, so much information. But, okay. NIC teaming allows multiple network interfaces to work in tandem to increase available bandwidth. Also provides load balancing with fault tolerance. Another term for this is load balancing and failover. Load balancing distributes traffic between 2 or more interfaces, providing an increase in overall network throughput. Failover is the ability of a server to recover from a network hardware failure by having redundant hardware that can take over for a device failure. You can configure NIC teaming on a Hyper-V host server and allow the VMs running on the host to benefit from the NIC team. Or you can configure NIC teaming in the guest OS of a VM to provide a dedicated NIC team. Configure NIC teaming using Server Manager or PowerShell. From Server Manager, click on Local Server, and then in the left-hand column of the Properties page, you'll see the link for NIC teaming. Click the link, brings you to the NIC teaming configuration page. From PowerShell, you can list, create, remove, rename, and set properties of a team using the pile of commands that are listed there on the bottom. Okay, so this is what it looks like when you're going through here. NIC teaming modes. When you create new NIC team, you configure the teaming mode and the load balancing mode. 3 teaming modes are switch, independent, static teaming, and link aggregation control protocol. Load balancing mode, address hash, Hyper-V port, and dynamic are the ones of those. So NIC teaming on the VMs, you use the same procedure as you do on a physical computer, and this is what that screen looks like. I'm sorry, I have a cat that keeps leaping up to the side and I don't want them to run across the keyboard. Implementing switch embedded teaming. Set is a new feature that allows up to 8 identical physical adapters on a host system to be configured as a team and mapped to a virtual switch. Set is targeted for enterprise servers with very fast NICs. Set supports remote directory memory access or RDMA on virtual network adapters. You must enable RDMA on the virtual network adapter created on the host system first in order for that to be there. Synthetic versus legacy network adapters. Synthetic network adapters are network adapters that use synthetic drivers and Hyper-V and offer much better performance than the legacy network adapters. These are available on Generation 1 VMs only if integration services are installed. With a Generation 1 VM, you should use a legacy network adapter in the following situations. The guest OS doesn't support synthetic network adapters. You need to PXE boot, or the VM needs to access the network for some reason before the operating system starts. Now note that Generation 2 VMs don't support legacy network adapters, so you'll be using synthetic network adapters on those. Configuring fiber channel adapters. A apparently I'm going to put an L in there, fiber channel adapter allows a VM to access fiber channel storage directly from a VM. Access to shared fiber channel storage also enables administrators to cluster VMs to provide application and node level fault tolerance across multiple Hyper-V servers. To use fiber channel on a VM to connect to a SAN, you must first create a virtual fiber channel SAN in Hyper-V Manager. You can then add a fiber channel adapter by using the add hardware option to VM settings in Windows. Now, in case you're not noticing the pattern, but I'm sure you are, basically all of the things in VM version are just mirrors of what you would do on a regular physical server. It's just a virtual version of it. So as you can see, this is what that fiber channel adapter looks like. Nested virtualization. This is actually one of the coolest things I think about virtualization. This provides the ability to run a hypervisor inside another hypervisor. Can be implemented with VMware and other virtualization platforms. Nested virtualization in Hyper-V is supported only in Windows 10 and Windows Server 2016 and later. Both the host machine and the VM must be running Windows 10 or Server 2016. The VM that's running Hyper-V cannot use dynamic memory while Hyper-V is running. You must turn off the VM to adjust its memory. You cannot live migrate a VM that is running Hyper-V. So the way to think about nested virtualization is, and this is actually something that we do when we do the virtualized machines for you guys. So if you think about, you have your hardware, you have your hypervisor, and then you can have hypervisors within hypervisors. And it's really cool for situations like we have within our Csec department and everything like that. Implementing Linux and FreeBSD virtual machines. Hyper-V supports Linux and FreeBSD VMs with no special configuration if you use emulated device drivers. For the best performance, you need to install Linux Integration Services, LIS, or FreeBSD Integration Services, BIS. Some of the newer Linux kernels include support for integration services. If the distribution you wish to install doesn't include them, you can download them from Microsoft's Download Center. FreeBSD releases beginning with version 10 provide built-in support for integration services. I believe Ubuntu and Kali have that built in. I'm not sure. I think Parrot does. I'm not sure about some of the other ones though. Okay, so that was a whole bunch of stuff crammed in there. And stop sharing. Now, I'm going to hit stop on this because that's the end for that particular portion, but I have stuff for questions.